Hi, I'm Eric, and I'm going to talk about the HTML5 sizes attribute, which allows you to do responsive images on the web. A little summary of the talk before we get into it. I'm going to talk about what sizes is, why it's necessary for responsive images, why it's such a great, elegant design, then why it's so terrible to use sometimes, and then what you can actually do about that. Before I get started, I did want to take a quick little survey. How many of you have actually implemented a site with responsive images of any kind? More than 50%? That's good. How many of you have actually used the sizes attribute on a site? Oh, much less. That's really interesting. OK, cool. This will be a good talk. All right. I did want to just introduce myself quickly. Like I said, I'm Eric. And I'm a developer evangelist at Cloudinary, which is an image backend for web and mobile developers. We help you manage image upload, storage, manipulation, and delivery. If you're doing any of those things with images, and I'm pretty sure that you're storing and delivering them, Cloudinary can help you do that better. It can automate your workflows, simplify your solutions. It's good. But before I worked at Cloudinary, I managed the web store of a tiny fine art printmaker in Denver, Colorado. And just happened to get really upset with the way that images were working within responsive layouts. And yada, yada, yada. I was spending hours at night reading WG mailing lists, and then writing a weekly newsletter for the Responsive Images community group, which ended up doing the specking out and then implementing some of the features I'm going to talk about today. I do still like art. I used to work at that print shop, and I live, like Peter said, on an island now, where I kind of wander around and take weird pictures of kelp. The island's called Orcas Island. If any of you are out in the San Juans, come by, say hi. It's really beautiful. But enough about me. Let's talk about sizes. Actually, wait. Before I can talk about that, I need to talk a little bit about what we mean when we say responsive images. So, Sarah was talking about SVG images, which are intrinsically flexible. Bitmap images are static. They have a fixed resolution. They're fixed height, fixed width, fixed content. Unlike the laser panda machine, you can't responsively design a JPEG and outfit it with dynamic properties that adapt to fit different contexts. It is what it is. And in order to do that kind of adaptation, you need to add other layers on top of it. So a responsive image is an image that can vary and adapt to fit variable contexts. What kind of context are we talking about, and what kind of adaptation might we be doing? One axis of variability is variable image formats. So different browsers support different formats, and there are a few tools that you can use to make sure that every browser gets the best image format that it supports. But we're not going to be talking about that today. Another axis that we're not going to be talking about is variable image content. So this one is actually really exciting. While the rest of the talk is going to primarily be about performance optimization, variable content images can be visually responsive in the same way that our dynamic layouts can be. This is about design more than performance. But again, we're going to set that aside and talk about variable resolution images. So these are images whose content isn't actually changing. They're just scaling up and down, sometimes by quite a bit. On a phone, in this example, that source image might only need to be a few hundred pixels wide. But on a 5K display, a big viewport in a 5K display, you'll need thousands of pixels of width to fill that physically large and high-density display. Sometimes I affectionately refer to this as the squishy images use case. And in order to solve it, we want to send every user just enough pixels that they'll get a crisp image with as little wasted overhead as possible. So how do we do this in HTML? We'll start with a decidedly unsquishy static image, just a source. And to make it responsive, we're going to add two new attributes to it. One is called source set, and the other sizes. So source set allows you to include multiple alternate sources in a comma-separated list. The browser can choose one of these sources out of the list. We describe those sources with these little width descriptors over here, so the 400W, 800W, 1200W. And those tell the browser, here are the three images, here are their widths. You can choose among them. And it is totally up to browsers to choose which one to load, which is actually pretty interesting. But right now, with just the source set, they don't have quite enough information to make a smart choice here. Because when we're picking and loading a resource, like this one, in order to load a size appropriate for the size of that box on the layout, we need to know how wide that box is. And when browsers first encounter the image element in markup, they have no way of knowing that. When the browser is chunking or downloading a chunk of HTML, every time it sees an external resource, it fires off a GET request for it immediately. So as soon as it sees, less than img src equals and then a source, it immediately wants to go out and get that image. There's a good reason for this. Images are often the heaviest resources on the page, and we want to start loading them as soon as possible. But there are no guarantees at that moment about what's going on the layout side of things. We probably haven't even finished downloading the CSS. We almost certainly haven't parsed it or calculated the rendered sizes of all the elements on the page. So when it needs to pick a source out of the source set for this image, the browser has to go on just a few facts about its environment, like the screen density and the viewport size, and then what it has right there in the HTML. So sizes says, OK, let's just put the box's layout size right there in the HTML, like this. So here's a typically simple example that you might find in an Intro to Responsive Images article. This sizes says, this image is going to be 100 VW across. It's going to take up the full width of the viewport. Sizes can take CSS lengths, so we're not limited to just VW units. We can put any old length in there, like 800 pics, 40M, or I can even get fancy with some calc functions. The fanciest thing that you can do of all is supply multiple lengths in a comma-separated list and let the browser know which one you want to use with media queries. So here, for instance, we've written a sizes that captures the width of an image with, that has a max width of 40M. If the viewport is bigger than 40M wide, that media query, mid-width 40M, evaluates to true, and we get a size, the sizes evaluates to 40M, that first value. If the viewport is smaller, the media query is false, and we skip it, going to the next value, which is 100 VW. So let's say we've got a viewport that's 750 pics wide. What happens? First, the browser evaluates the sizes to get the layout size of the box in CSS pics. So 40M is equal to 640 pics. So the browser looks at the media query and says, yes, this is true, 750 is greater than 640, and uses that length, 40M. So now the browser knows that the width of the image is 640 pics wide. What it does next is sort of interesting. It takes the width of each resource, those W descriptors, and divides them each by the layout width of that it got from sizes and CSS pics. And it arrives at an image density for each image. These image densities express how many pixels each resource has relative to the IMG element's layout size. These densities are what the browser actually uses to choose an image to load. So if we're on a 1x device, we'll probably end up getting image.jpg because it's got the density that's the best match for the display. If we're on a 2x or 3x device, big.jpg is a better fit. And if we're on a constrained data connection or have picked some user preference that says, save data, please, we might very well get small.jpg. And that's how it works. That's how source set and sizes work together to solve the squishy image use case. And sizes is obviously a fundamental part of this. It solves the problem of how we know the image's layout size before we have any CSS in a very direct, one might even say blunt, way. It does this by sticking the layout size right in the markup. And I have to say, having seen some of the other solutions that were tried and proposed when the stuff was being spec'd out, they all address this problem less directly and were therefore more complicated and worse. This is the best. After years of thinking about this is the best that anyone could come up with. And the problem that it solves is so fundamental. Even client hints, which is sort of an emerging responsive images spec, couldn't really shake it. Client hints tries to move as much of the complexity of responsive images as possible out of markup and out of browsers and into HTTP headers and servers. But while it manages to completely eliminate the need for source sets, it couldn't find a way around sizes. You still need it when you have a client hints enabled URL, which is really a shame. Because honestly, between the two, source set and sizes, if I had to choose one to keep and one to kill, I would kill sizes. It's so often just such a big pain in the butt. It forces you to break at least two basic principles at the same time. The first is, of course, the separation of concerns. On the web, we like to keep our content separate from our layout. This is a lesson we learned a long time ago when we moved away from font tags and table-based layouts. Sizes one giant leap backwards for the separation of concerns. It sees your content-focused markup and says, why don't you go ahead and stick some style information right in there, But it gets worse. it makes you repeat yourself. Sizes forces you to take all of your good, dry CSS, think about it really hard, and figure out how to distill it down into one sizes value. You know, even with a simple layout like this is basically just a tube of content with a max width on it. There are a lot of different moving pieces, making things hard to figure out initially. Worse, once you've written the thing, it's really hard to trace things back from the sizes and explain it based on the CSS. So when your sizes values and your CSS inevitably get out of sync, it's super hard to update and maintain. And again, this is a really simple layout. Things can get much, much worse. I'll start by just talking about M units. M's and sizes go together about as well as peanut butter and a slap in the face. Why? Because the size of an M in CSS is context dependent. And as we've learned, sizes doesn't know very much about context. So while the size of one M in CSS can vary based on where it is in the cascade, one M in sizes is always equal to the browser's default font size, which is usually 16 pix. Here's an example. Let's say we have a simple layout with a fixed 20M sidebar and 1M of padding all the way around our images, which are appearing in the main content. So to figure out the sizes value, we can take the width of the entire viewport, 100 VW, and subtract 20M for the sidebar, another 2M for padding, and we get this seemingly simple sizes attribute, 100 VW minus 22M. Seems simple. But let's say we changed our root font size to be 18 pix in CSS. Now 1M everywhere further down the cascade is going to be equal to 18 pix, not 16. Sizes doesn't get that memo, and so if we want completely accurate sizes, we need to update all of our sizes values accordingly, changing the 1M to explicit 18 pix values. And then let's say we tweak our sidebar a little bit so that the font size is a bit smaller over there. Now we have two different M values which we need to capture in our sizes. You can see how this is escalated rather quickly. The worst case scenario for all of this is probably fluid type sizing. This technique, also known as CSS locks or responsive type sizing, uses M's, the calc function, and viewport relative units to do some clever math and scale the text size dynamically based on the viewport width or the viewport height, based on a specified minimum and maximum. It's a wonderful technique, but as you can see, it's not an entirely simple one, and all of that complexity makes its way down into our sizes values. Flexbox is terrible too. Here's a simple flexbox-based grid. The figure elements here have a flex basis of 10 M's, but they're also flex growing to fill the rest of their container's available space. That's kind of what Flexbox is for. Here's what that looks like. And as you can see, the result is some decently squishy images. Those images are going up and down. How do you encode that squishiness in sizes? The only real way is to stop trying to work from the CSS out and start working from observed widths back in. So I can break out my dev tools and measure where we split from 1 column to 2 and 2 columns to 3. The 1 column to 2 column split happens to be at 977 pix. The 2 to 3 is at 1506. And I can use those measurements to write my sizes like this. When we're wider than 1506, there are 3 columns, so the layout width of the image is going to be 100 VW over 3. When we're between that and 977, we've only got 2, so divide 100 VW by 2. Otherwise, we've only got 1 column, so the layout width of the image is going to be about 100 VW. Now, if we expand that window out just a little bit wider, our content breaks into 4 columns, except for those last 2, which, their size is actually not only dependent on the CSS, but also the number of content items in that list. So you start to think about, okay, now every time I update my CSS, I have to update my sizes, but also anytime I add or remove content from this Flexbox grid, I also have to change every sizes in the page, or at least some of them. This gets terrible fast. And of course, these are all nice little reduced test cases. Out in the real world, things are even messier. Recently, I was working with Sarah's colleague, Chris Coyer over at CSS Tricks, on that site's responsive images. I thought, CSS Tricks is great if anybody in the world deserves the most perfect sizes values that have ever been written. I'm going to write them for CSS Tricks. Unfortunately for me, the site uses both fluid type and a Flexbox grid, so things got really ugly really fast. This is a monstrosity. It took me hours. Don't do this. Of course, a week or 2 later, Chris whipped out like a weekend redesign, and I had to redo the whole thing all over again. So, one last point. sometimes a site's layout is dependent on not only things that you can't actually, or sorry, the site's layout is dependent on things that you can't actually capture in a media query, like user input. In those cases, no math can save you. For example, here's one of my favorite websites on the internet, jeremykeithsactio.com, which allows you to choose between a tremendous array of layouts that look like they were originally designed in 2002. Within each layout, we need different sizes. And without a lot of horrible JavaScript that would sort of defeat the point of the whole thing, that would be impossible. So we're stuck with sizes, and it's kind of ingenious, but also kind of terrible. What can we do about this sad state of affairs? First of all, something I haven't mentioned yet, sizes was explicitly designed with the idea that it was just an estimate of the layout width of the image. It doesn't need to be pixel perfect. It probably shouldn't be. How fuzzy can they be? I mean, imperfect sizes values impact is sort of complicated to figure out, and it depends on the gaps between the widths of the resources in your source set. But let's say your sizes are off by 50 or even 100 pixels. If the gaps between your resources in the source set are, if you have a resource for every 400 pixels, your 100 pixel wrong size is only going to make the wrong resource be picked about a quarter of the time. And that wrong resource is only going to be one size too big or one size too small. We're not going to be making a large error, like sending our largest image to the smallest displays. So just ignore padding and use the flex basis without worrying about the flex grow factors. You know, estimate aggressively. You can just eyeball this stuff. For example, here is a nice responsive site that is not open. The BBC homepage. And if I can get a hold of the end of that window. OK, so let's look at just this image here. So at this viewport width way out here, it's at sort of a static width. As we get smaller, it goes from taking up half the viewport to all of it. So all we really need to do here is figure out where it stops moving, where it moves from 1 to 2, or taking up 100 the full width to half of the width, and then not worry about the padding, and not worry about any of the, if there's like responsive type sizing or anything happening here, and just have 3 comma sizes with just 100 VW, 50 VW, and whatever that fixed size is. It can be done in minutes. Maybe at first glance, a slightly more complicated, publicly funded news outlet website, NPR.com. The width of that image is kind of jumping around a little bit. We've got the sidebar that pops in. It's kind of bouncing around. It has that same place out here where it stops growing at all. And you might be tempted to try to use that breakpoint as a value, and then try to figure out what it's doing down here that's different than what it's doing out here. Don't do any of that. It really, in the grand scheme of things, stays about the same. There's maybe like a 25% difference or something until we get really small. So just figure out this fixed size here and put that in your sizes as a pix value, and you'll probably be fine. How will you know when you are not fine? That is a good question. Which we'll get to later. Because if you really just can't even start with this size of stuff, it seems too hard, there are a couple of entirely reasonable ways that you can just not even try. The first is just to use sizes equals 100 VW everywhere. With this, we're going to be loading an image that's sized to fit the full width of the viewport. So small, low-density screens will still get small, low-density images. Big, high-density screens will still get high-resolution images. And all of the error is going to be in the too big direction. So everybody's going to get a crisp image. This is actually the value that gets used by all kinds of things that have to pick sizes for things when they have no way of knowing anything about the page's CSS. For instance, browsers. This is actually the default value. If you omit sizes, that's an error, but then behind the scenes, the browser actually still wants to pick and load an image, so it uses 100 VW as the value that it uses to do that. Also, CMSs like WordPress and Drupal that have to write out responsive images when they're using themes that haven't been written with that in mind, use this or something like it in the absence of any better information. A slightly more interesting way to give up is Alexander Farkas's lazy sizes library. It's a lazy loader, which automatically authors perfect sizes attributes for you. Because you see, the whole problem that we're trying to solve here with sizes is knowing the layout size of the image before we know the page's layout. When we're lazy loading, we don't have that problem. We're loading way after layout is complete, so lazy sizes can measure the layout as it exists already and use that information to write sizes attributes. Some pros of this approach, it solves all of the problems that we've outlined previously. You get to separate your concerns, you get to keep everything really dry, you get to not author sizes or maintain sizes. It's great. But there's some bad sides to it too. It makes responsive image loading functionality JavaScript dependent, which is no good. And what you're doing when you're doing this is intentionally delaying image loading. For images that are visible above the fold on first load, they will come in much slower than they would if you were using a sizes solution, because we have to wait for the CSS. No matter what you're doing with responsive images, with source set sizes or the picture element or anything, you should always use this tool. This is the most important slide in the talk. It's called resp image lint. It's by a guy named Martin Asperger, who lives in Germany. And if you take one thing away, use this tool. It's a linter for common responsive image mistakes, and it catches all kinds of stuff for me all the time. When it comes to sizes, it does something particularly interesting. It allows you to actually directly measure the negative impact of your estimates in order to see if they're worth improving. So let me show you. Here is the website of my old employer, Pressure Printing, in Denver, Colorado. And we're going to run the linter on this. And what it's actually doing is running a phantom browser and resizing it to a bunch of conceivable widths, and then testing the rendered widths of the image against the sizes values. And I took my own advice here and just used estimates. So it's going to complain about most of the images on the page, but we can actually see how much we were wrong by. These are all worst case scenarios. So for image number 1, we had a 15% difference. Turns out that wasn't that many pixels. What's that? My math is bad when I'm speaking. Image number 2, we were off. It should have been 76, and we actually, the size is evaluated to 57, not a big deal. 141, 175, again, not a big deal. If you saw something in here that was like, should have been 100, was actually 1,000, then you need to go back to your drawing board and think about what you did. But until that time, don't worry about it. So, recommendations. If you're developing a page, don't worry about sizes. Any time you spend on it in development will be wasted because your layout will change and you will have to change your sizes and you'll be sad. Just use the full-size image or just the source. I mean, I often, in development, just put full-size images directly in the source. Don't worry about source set, don't worry about sizes until later. Just before production, you can just eyeball it, like I showed you with those other sites, and RISP image lint it to see if there's actually a mistake that you need to care about. If there is, and only if there is, it's time to take some more measurements and think hard about all of the things that are affecting the layout width of your image and try to write a sizes value that captures that dynamic width more accurately. Again, don't do this, if at all possible. It'll just cost you a lot of time now and maintainability down the road. Lastly, of course, if you're OK with lazy loading, just use lazy sizes and call it a day. OK, so the last question. The situation that we have now is clearly a little bit less than ideal. Is there anything coming down the pike that's going to make it better? I'm here to give you a resounding maybe. Our first and best hope is better build tools. None of the concerns I've expressed today were really unanticipated. When source set and sizes were being originally spec'd out, often someone would come into the discussion and express concern over, say, the muddling of content and layout, and they were always met with 2 responses. First, an explanation that while sizes is somewhat regrettable, it's the best tool for the job, and that's true. Second, a vague hope that maybe someday soon, sizes would be written automatically by computers and not by humans as a build step. Well, here we are 3 years later, and we've had no such luck. No such knight in shining armor has come along to save us. But there's still nothing about the problem that seems impossible. It's just quite hard. I was talking to the guy behind Resp ImageLint about somehow turning the sizes error measure that he's built sort of inside out so that it could be sizes authorer. He agreed that it seemed possible, but hard. So it hasn't happened yet. From the specification angle, I have some bad news. Things are going to get a little bit more complicated before they get any simpler. One limitation of this whole system that I've completely glossed over until now is that right now, sizes only works, and sizes in source set only work with width-constrained images, images with a specified width or a specified max width. If you have a height or a max height on your images, these attributes cannot help you. So a proposal has been floating around for a couple of years to update source set and sizes so that it can deal with height-constrained images. Here's an example of what that might look like. We have an image here that has a specified width and then a max height of 100 VH, so it's never going to grow bigger than the viewport. I don't know if any of you look at photography websites, but responsive photography websites have a real bad time with allowing you to see all of a photograph when it's a portrait instead of a landscape. Those things get real big. So to enable this, to enable responsive functionality with images like this, in source set, we would get an H descriptor to go along with our W descriptor. And then sizes would take two lengths, both a width and a height, and a contain or cover keyword so that the browser knows whether to use a size that fills or fits within that box. This is great. This is maybe needed, but it's also more complex, which is not the direction that we want all this stuff to go in. Ultimately, what we want, I think, is to somehow eliminate the need for sizes altogether. And the only way to really do that is a native way to somehow opt into having the browser wait to load some or all of the image data until after layout is complete. So maybe this is tied to some form of native lazy loading. We could have a native lazy sizes functionality. Maybe it's tied to some form of progressive loading. So everybody would get the smallest size of the image immediately, and then somehow after layout, after we can measure how many pixels we actually need, we can layer that additional data onto that small starter image as needed. A guy named Yoav Weiss actually threw out a proposal for just such a thing about 4 years ago, called responsive images containers. But it's been dead for years, which is unfortunate. Maybe someday. Okay, that's about all I have. Thanks, everybody, for coming out on Friday night.